Thanks for having me here. It's a pleasure to be here, my first time in Gdańsk as well. My name is Ray. I'm a developer advocate for the Google Cloud Platform. And what that means is I'm an engineer. I love to write code and write applications, but I also like to bring some of the latest Google technology to developers all over the world. And I love to hear about your feedback and your comments so that we can also make our products better as well. So if you have any questions, please reach out to me. The best way to reach out is on my Twitter, @Satanism. Aside from technology, which I've been doing for the past 15 years, I love to travel. And if you have, if you like to see some of the photographs I've taken, you can check out on Flickr as well. Now, for this talk, I have written an application. This is probably the best-looking application I can ever write. I'm not a front-end developer, as you can see. That is why this is in black and white. But it is also the best application I can write because it's very simple. And it's got two primary functions in it. It's a guest book. Basically, you can say your name and say hi, and you can say greet, and it's going to record this data and say hello to you. Okay. Now, if you look at this from a traditional view, this is very simple. It is a very simple application. Well, it is. It's got a front end, and it's got two services behind the scenes, and each of the service has its own function. And to have some kind of session replication, I'm using Redis behind the scene. And also to store data, I got MySQL running behind the scenes as well. Now, let's go to production. I love to hear that. How do we take this into production? Well, again, traditionally, this is what we do. We have to package up this application first. And even though we develop the services separately, potentially as different functionalities, but ultimately we package them into different jar files, right? They're just classes. And then we put multiple jar files into a bigger jar file. We just name that, and we name it a war or a year. It doesn't matter, right? But at the end of this, you have this one monolithic package you need to deploy. And that is potentially a problem in some cases, not all the cases, but in some cases that's a problem because if the services need to be scaled out separately, well, you can't because they're all packaged together, so you have to deploy them together. When you need to iterate fast on one of these services, guess what? You have to wait for other packages to be updated as well, and you have to wait for that release cycle. So now you have potentially some issue with how fast you're iterating and pushing out into your production environments as well. But not only that, I've been consulting for a long time. And every time before a project starts, 6 months, 9 months before the project ends, I have to tell the business how many servers do I need? How big is that infrastructure? What does that infrastructure look like? I don't even know what the application needs to do, but I need to tell them the number. Why? Because we often need to procure these machines, and we have to wait for them to be cabled, to be installed, to be set up, to be configured. And that is not an easy task. Why? Because once the machine gets in, you have to tell somebody the right version of the operating system to run on. You have to tell them the right system libraries to install, the right dependencies to put on those machines. And finally, if you're writing a Java application, you gotta have the right version of the JVM, the right version of the Tomcat or JBoss or whatever. And then you have to configure GIND, you have to configure the XML files, blah, blah, blah. The list goes on. And after all of that, you finally deploy this app. And guess what happens? It probably doesn't work the first time, at least not for me. Why? Why does that happen? There's almost always some kind of configuration issues. Now, I cannot see the hands here because of the light, but I'm wondering, has this ever happened to you, where you deploy something into production, and you get this production bug report from your user? Say, oh, this thing doesn't work. But then you go to staging, you go to QA, you go to your own machine, everything works. But it just doesn't work in production. Why is that? It's almost always, again, a configuration issue. And in my experiences, there's always there's one or two people on the team, in a development team, who's actually able to write a very long and complicated document. And this document will say a couple of things. Number one, how does a new developer who gets on the team can set up their own machine so they can start developing? The other side of it is how do I set up each and every one of these environments because they're almost always a little bit different. And that is why we always have some issues. And then we don't just do this to one of the machines, we do it to multiple ones, because you have a cluster of machines you need to run your production load. And if you're lucky, this is all scripted. But no matter whether we're scripting it, or if we are doing this manually, at the end of the day, this is what we do. We turn these machines into something that can run my application and potentially only my application. If I ever need to repurpose it, guess what? I have to format it, reinstall it, go through another long and complicated documentation on how to reprovision it, and now I can potentially reuse it. And typically, we only run one app, one instance of the app on that one instance of the machine, because it's so hard to set it up. In fact, if you run multiple, you may have issues, right? You have to deal with port conflicts and all of the different things. Speaking of port conflicts, if you do actually run multiple application instances on the same machine, well, guess what? They cannot run the same port. So now you have instances that's running on 8080, 8081, 8082, blah, blah, blah. And then also, almost always, there's this big, giant spreadsheet documenting exactly what instance runs where and what port needs to talk to what. And somebody have to maintain it, right? And this problem doesn't go away. This problem actually is going to get worse if you don't have the right tooling, because if you're looking into a microservices architecture, then you have even more of these instances you have to provision. And because you may actually break out some of these components into individual instances, well, now rather than just having one monolithic app, you got 3 apps. And every one of them will have more than 2 instances potentially, and now you just have to manage all of it, and it can get difficult, right? There are a lot of things that you have to understand and also deal with. Microservices is not something that you just say, oh, let's do that tomorrow, right? There are a lot of other consequences you have to think about. Now, this is where container and container orchestration can actually help a lot. Well, first of all, with containers, you can actually bundle these applications into not just the application deployable, but fuse it with the actual runtime image as well. So in the container image, you have the application code and the runtime code that's necessary to support our environment. So no longer do you need to morph every machine into something that can only run your app. You can create this smaller image where this image is made to run this app, and now any of the machines that you have can pull down the image and run it. And actually, Google, the reason I'm here, is that we actually have a lot of experiences in running containers. And in fact, we run everything in container. I do mean everything, okay? And except for coffee machines, of course. But like anything else, if you can think about like Gmail, Google Search, everything else, in software, we run them in containers. We launch over 2 billion containers per week. This is the scale that we're running at this moment. By the way, this is US billion. What that means is only 1,000 million. It's not the same as the European billion, which is like a million, right? So it's only 1,000 million containers per week. And as a developer, as an engineer at Google, this is what we can do. To deploy an application, we don't say, let me deploy this to www.1010.google.com. Right? This is what a lot of the traditional enterprises do. Like every machine has a name, and you specify which machines to deploy to. What we do is that we write a descriptor, we write a declaration saying that I need to run this app in a cluster. I don't care which machine, but this is going to be running in a cluster. And a single cluster at Google is called a cell. A single cell can be composed with a median size of 10,000 different machines. That's a single cell. That's a single cluster. And for me to deploy, all I need to say is, go ahead and deploy into this one cluster. And this is the binary application that I want to deploy. And at Google, we're using static binary. So this is just a big static binary. Could be 70, 80 megabytes large, for example. And we can give it some startup command line arguments. But most importantly, we bin pack our processes, potentially onto the same machines. And a lot of us today outside is using VMs to carve out resources, right? Or that we use machines to size it up so that we use it to, hopefully, the right sizes to run my app. But what we do is that we use kernel constructs called C groups to potentially isolate the resource that a process can use, and multiple processes can share the same machine without having to interfere with each other. And in fact, we actually contributed that code into Linux kernel. It's called C group, and that's what makes all of the containers technology run today. Okay? So what we can say is this app, this process can only use 100 megabytes of memory, 100 megabytes of disk, 10% of the CPU, and most importantly, how many instances do I need? 5, for example, or I can scale this up to potentially Google scale, 10,000. Okay? And this is our internal system where we can push our binary into a central repository somewhere, like a share file system, so that every machine in the cluster can get to. We'll write that configuration file, we'll push it to the master node. It is called Borg master. That is our internal system. It's called Borg. Once we push this config to Borg master, behind the scenes, there's a scheduler that will say, oh, I need to go ahead and deploy this across my cluster. Where do I deploy this to? The scheduler will wake up and say, I need to deploy 5. It's going to ask the machines, hey, do you have enough capacity to run this? If you don't, that's OK. It's going to move on. And it's going to say, hey, this machine, do you have enough capacity to do that? And if you do, go ahead and grab this image, right, and start running it. That's basically how we do this. Now, if you look at our scheduler, it just occurred to me that in some companies, this is actually a person behind the scenes, right? There's a request to deploy, right? So that will be the config file. And then you give it to somebody, and that person has to fulfill it. But we just automated a lot of these things. And very quickly, we can provision our app across the cluster. And we can do this very quickly in about like a minute and a half or something to deploy, like, say, 10,000 instances of this app. And this is what we call container orchestration. And outside of Google, of course, we cannot use what we use internally, right? At Google, we use Borg. But we actually took the experiences of running container at scale, and we created the project called Kubernetes. And now this is actually a project owned by the Cloud Native Foundation. So this is a collaborative project that is no longer owned by Google, right? It's actually owned by the foundation, and we have a lot of contributors. The takeaway here is that it was designed to orchestrate and run containers at scale. It was designed to support multi-cloud and on-prem deployment out of the box. And it is fully open source, so anybody can contribute as well. Now, the way it works looks something like this. It's very straightforward. As you can see, I literally copy and paste it, right? I copy and pasted the previous slide, and I renamed a few things. Now, of course, this is a high-level concept. The code base is very, very different, but the concept is very similar. Now, rather than a static binary of a Linux executable, now we have a static binary that's in the form of a container image, because the container image has everything from the link dynamic libraries that you need to the application code itself. So you push the container image into a central repository, and then you write a config file, potentially push it to the Kubernetes master. There's a scheduler behind the scenes that will schedule your workload and containers onto the machines that can actually run the app. Now, I know that some people may have run containers already, and I have asked this question before. There's always some people who are actually SSH into the machine themselves and to do a Docker pull themselves. Well, just think about this as, well, that's all automated now. We can actually do all of these things for you automatically. And for you to deploy something, there are two ways. One is to write the command line. You can, from the command line, you can just say, go ahead and deploy. Or you can write a config file, and you can push the config out, which is the way I prefer it, because then you can check in your infrastructure as code. Or in this case, I would argue this is application architecture as code. So I can say, I need to run an app, and this is the container image I want to write. I want to run, and this is how much resources this container can consume, and what port this is running on. I can document everything in this specification, and I can push it to the Kubernetes cluster. Now, the real takeaway here is that when I think about how I did things before, it's always about individual machines. When I'm provisioning and managing my applications with Kubernetes, through the eyes of Kubernetes, I'm seeing every machine exactly the same, potentially. And they are just treated as a single resource pool. And I can just tell Kubernetes what to deploy and how much CPU do I need. and it's going to go ahead and figure out which machine has the best fit. But in addition to that, it's going to try to potentially bin pack, so you can run multiple processes on the same machine so that they don't have to interfere with each other in terms of resource competitions as much as you can, right? So let's take a look at what that may feel like. I got 15 minutes here. I'm going to start off with something simple, for example. So let me do something. All right, so I'm gonna get rid of that. Gone. I just deleted my backup. Okay. So what I'm going to do is I'm going to create a very simple microservice in this case. I'm going to just be able to return hello world or something and say hi to you, right? So I'm going to say, well, I'm going to create a class called hello world service. I'm going to have a method called, by the way, I'm doing this in Groovy with Spring Boot. I'm going to have a method that will return, based on my name, a JSON payload with the greeting message inside. So potentially something like greeting. I'm going to say hello, plus the name I just pass in. And to make this a RESTful thing, I need to add a RESTful controller, a REST controller annotation to the top. This is just Spring Boot construct. And then I can map this method to a URL. So I can do something like hello. And for the name, I'm going to pass it in from the URL too. So I can have this little expression there. And then with another annotation, this basically types up the pipelines. So now I should have a RESTful process that will take in the name on the URL and return something to me. How many people think it would just work out of the box like that? I cannot see any hands. Wow, this is tough. Well, it works. Whew. Not bad, not bad. So I just created the service, and I just started it with Spring Boot. And if I go to port 8080, hopefully, I say, hello, Ray. Oh, there we go. Not bad, not bad. So that's my application. Not bad. How do I deploy it? Well, there are two ways, like I said. Well, first of all, I can create the jar file. Right, so I'm going to Spring jar it. I'm going to say hello world.jar. I'm going to create a jar file. Now, this is a executable jar, so you can actually just run it, and you can say hello world. Right, that will just run. That's fine, but remember, you can of course deploy this jar file just as is, but before you do it, you have to package up the JVM and everything else, right? So if you do it the traditional way, what you still have to do is to create that machine, install everything manually, and then just deploy the jar. Now, in container world, what we can do is we can create a new container like this. Basically, I can use a base image that has potentially Java 8 installed for me already. I'm to go ahead and copy in the hello world.jar into this container image. And for me to start it, I'm going to write an entry point, and I'm going to say I'm going to run the Java command with the jar argument, and I'm going to run this jar file. And that's it. And with that little instruction, what I can do then is to create my Docker container. So I can say docker build-t. Oh, I'm going to say docker build-t, Stalinism, in this case, hello world demo. Okay. Now, if the internet is fast, this actually should create my container for me. As you can see, the internet is not very fast right now. Okay. But luckily, I already have this up and running somewhere. I have another image there. Oh, OK. Oh, and luckily, this actually finishes. So let me see if this actually works. So if I want to run this container, I'm going to go ahead and run ti rm. And now, this container image, if I got it right, it's got all the base operating system components in it. It doesn't have the kernel, but it's got all the right dynamically linked libraries in it. It's got the Java JDK installed in it. And it's also my app. And now any machine, any clean machine with container or a Docker container running, it can actually run this app. Okay. So why don't I just go ahead and push it as well? So I'm going to Docker push. I'm going to push it to a central repository somewhere. So I'm going to do that. Push my repository to in this case, to the Docker registry. Now, anybody here who gets this URL right now, gets this coordinate, can also run the app. So that's great. What then we can do is by using Kubernetes to ask Kubernetes to deploy this app into a cluster of machines. Then this is very straightforward to do. I have already provisioned 5 machines, 5 VMs in Google Cloud Platform. Actually, it's just running there right now. It's very, very easy to create a Kubernetes cluster on Google Cloud, for example. It's just a click of a button. But just remember, you can run Kubernetes in many, many different environments, including your own data center as well. So in order for me to run this app, I can do the simple way, just to test it. I can say kubectl run. Make sure you can see it. Yeah. TI. Oh, sorry, not TI. I'm going to give it a name, hello world demo, for example. And I'm going to say the image is equal to the image I just created. Okay. And, oh, I forgot to add a few other things. But if I say get pods, you can actually see that from the API, from the command line, this container is now being downloaded. It's being scheduled to one of the machines that's running. It's being scheduled, and it's now up and running. Okay? This is how easy that we can deploy. And we can also scale it if we want to. But let me show you something more complex, right? So I'm going to go ahead and delete this deployment, for example. There we go. So if I don't want this application to be deployed anymore, I can just go ahead and delete it. And it's gone. And now this app is gone from my cluster, right? Until I need to run it again, it's gone. It's not there anymore. Okay. What I can also do is to, rather than using the command line to do that, because now you're just going back to scripting, right? You're just scripting everything. What I can do is to potentially document exactly what I want to deploy in a YAML file, in this case. Or you can use a JSON file if you want as well. So in this YAML file, it actually describes exactly what I want to run and how I want to run it. And the takeaway here, there's a lot to see here, but the takeaway here is that you can decoratively say and tell Kubernetes, well, how many instances do you need? And what type of application do I need to run? And also a bunch of other configurations if necessary. Okay? So I'm going to go ahead and deploy this service. So rather than use kubectl run, I can say kubectl apply. I got 7 minutes. Deployment. V1. Okay. Now, for this deployment, I got 2 instances. I can actually visualize it. Okay. So you can see now visually that these 2 instances are actually running on physically different VMs as well. And if you look closer, these containers, they are also being assigned a unique IP address. Now in Kubernetes, we call each one of these gray boxes a pod. A pod is really just a tightly coupled set of containers that need to live and die together. All the containers in the pod will live within the same physical resource and also sharing the same IP address. And typically, you only have one container in the same pod. Now, it's possible to run multiple containers in the same pod, but that use case is very limited. And if you'd like to learn more about that, come and find me after the talk, because that's a longer discussion. Okay? But the takeaway here is that my container is now deployed with multiple instances into my cluster of machines. And if I want to, I can scale this as well. I can go ahead and scale this deployment. It's called the hello world service. And if 2 is not enough, let me bring it up to 4. And now the scheduler behind the scenes will say, oh, I need 4 now. I only have 2. Let me go ahead and figure out where to run these 2 more instances. Okay? And more importantly, because every one of these instances have a unique IP, well, how do you talk to it? How do you actually talk to this application? Usually what we do is we put a load balancer in the front. And who sets up the load balancer? Somebody else. Well, in Kubernetes, load balancing is the first-class concept. It's a first-class citizen as well. So for me to expose this as a load balancer, potentially, is by creating a service. And this is a very specific concept or resource in Kubernetes. So I can go ahead and create a service, even though my app is called a service, but now I'm creating a Kubernetes service. And when I do that, if I open up the file, what it is going to be able to do is to create a load balancer for me that routes from port 8080, in this case, to port 8080 as well. That's the target port that's running on my app. You can also change the ports as well, right? So if you want to expose it on port 80, you can do that too. But what it effectively have done is that it created the load balancer in the front that knows how to route traffic to any of the instances that matches the description that says there's the Hello World application. And now you have a single IP address that you can use to talk to your backend services. In addition to that, we don't want to keep in track of these IPs all the time. So what do? We can actually just talk to it via the DNS name. Okay. So if I go and find a running container somewhere inside of my cluster, and usually there's this demo container that's running, in Kubernetes, I can just go directly into this running container. I don't know which machine it's running on. I don't really care. But rather than finding the machine and SSH into it, all I need to do is to say, get me into the shell, and it's going to establish the secure tunnel for me and just drop me into this container shell. Okay? And now I'm in the container. I can see what the container sees. I can see the files that the container sees as well. And just like a container within the cluster, I can also talk to, in this case, hello world service, port 8080. I can say hello Infoshare. And that actually got me connected. It routed my traffic to the backends. And now I can actually produce something even more complex. In my directory, I have checked in my entire stack of applications into the YAML file. Okay. So I'm going to go ahead and apply. I'm going to turn up everything. So in this case, I'm just going to go ahead and deploy everything I have. That's weird. Okay. So now I have deployed my front end, my backend services, and even my SQL as well. Now, some of you may be asking, well, hold on a second. How did you deploy MySQL? That is a stateful application. Don't you need to keep the data somewhere, right? Well, yes, you do. If you run this in a regular container, the data will be gone when the container stops or it got deleted. So the way you deal with it is by having an external value mount, right? In Kubernetes, we actually manage the value mounting for you as well. What that means is you can declare to say this particular app needs to have a stateful volume. And the volume can live in the cloud, for example. If you're running this in the cloud, we can provision a disk for you, and you can tie this mounting directly to the machine that's running the container and subsequently to the container itself. And if the machine ever goes away, or if the process ever needs to migrate to another physical machine, then we will unmount this volume, we'll remount it to where this container needs to be, and so that when the container starts, we have everything else connected as well. Okay? And for the very first time, now we should be able to see the application up and running. Okay. Hopefully, this almost always works. So let me just double check. Almost always. It always works. Yeah, let me see. So I got my application running here. Yeah, there you go. Just took a little time to create. And I can say something like, Ray, hello, Infoshare. Right? For this particular service in Hello World UI, as you have noticed, maybe, that in addition to the internal IP, it actually also provisioned an external IP as well. And the way that we have done it is also by going through the same configuration file, say hello world UI service. The only line I needed to write that was different from the other one is by adding the type code load balancer. Now, the real takeaway here is really that it works in any of the Kubernetes installations that you may have in different environment. Okay? So these set of files are exactly the same if you were to deploy this into a Kubernetes cluster running on Google Cloud. It's exactly the same YAML file if you were to deploy this on-prem. It's also exactly the same YAML file if you were to deploy this onto another cloud platform as well. So now your application architecture becomes portable. Right? You're not doing something just for that provider or for your infra. You're doing something that's more general, it's abstracted, and now you can do everything exactly the same way. In fact, if you run Kubernetes locally, which you can by using a tool called Minikube, you can run a Kubernetes single node cluster on your machine you can also use exactly the same YAML file. So now you can hopefully see the value of this. We can orchestrate from environment to environment, from QA to staging to production, with almost exactly the configuration. Hopefully, the only thing that you're going to change is really just the number of instances that you want to run. Now, I do have 6 minutes, it seems like. One of the things that I'm often asked to do after I deploy my application going to production, yeah, that's what we're talking about, right? We went to production. What happens is that often enough, we have to maintain it. We have to keep it up to date. Or potentially sometimes marketing department may come and say, wait a second, let's try something different. Or whoever, somebody may say, let's try something different. Let's change the color. Let's change my app a little bit. And to do that, you would have to modify the application. Okay? And then you create that container image. And then you have to roll it out. You have to deploy it again. Now, my experiences tell me that's always a long, long process to redeploy something. It's just like going to production all over again. It takes hours and hours, potentially, for me to schedule everything and actually perform the work. Well, in Kubernetes, if you do have that new container image you want to push out, you can just go ahead and edit my deployment, in this case, the Hello World UI. Okay, 5 minutes. And rather than running version 1 of my app, I'm going to go ahead and use version, not 21, I don't have 21 versions. Let me use version 2 of my image, okay? And as soon as I hit that button and say, go ahead and do that, what it should be doing, soon enough, is it's going to perform a rolling update for my application. What that means is it's going to deploy a new instance with the new version, and then take down an old instance when the new version is ready. Because in Kubernetes, we actually have built-in health checks as well. So you can configure the health checking, right? So you can say, don't route any traffic to my app unless if it's healthy and it's ready to serve. The same mechanism is being used in this deployment, where I say, go ahead and do a rolling update, but only continue if the new app is healthy. So it's going to try to rolling update, deploy new instances of my app, and I can actually see that because one of these apps is still deploying, I'm still waiting for it. So now there's one that's up and running, one is not. But no matter if I go back to my app, if I do the refresh, I should be able to see this new instance up and running as well. Hey, Hubert. Somebody just wrote in my, I don't know how this person found my IP, but good eyes, very good eyes. Okay, so hey, there, yeah, not bad, right? So actually, this color doesn't look so well, and for some reason, I'm still waiting for the container to download because it is a pretty large image, right? But for some reason, if I say that, hey, wait a second, this doesn't look as good as I thought it would be, or in my case, it's usually, oh crap, I made a mistake. I pushed a bug into production. It's causing a production outage right now. Like, no, this is bad. So what do? What do? You go back to that room, you stay in the room for another 4 hours for another deployment, right? Well, no, not in Kubernetes. What we can do is we actually have a construct that allows you to roll back. So all you need to do is to say, kubectl, roll out, undo, my deployment, hello world UI. And what it will also do, again, is now it's going to shut down my old instances, or in this case, version 2, it's going to do another rolling update across my fleet of application and services, and it's going to bring back up the previous version. It's going to try to bring it back to the previous state of my app. Okay? And if this actually finishes, there we go. It should be finishing up pretty quickly. And if I go back to my application, I can just tell my boss, all right, I'm done. Like, I think I saved the day today. Okay? So this is just a few things that Kubernetes can do for you. And there's so much more. There's so much more. And I do not have the time to go through all of these because of the session timing. But if you do have any questions, please come and ask. And there's one slide I was looking for. There we go. Yeah, there's much more. You can carve out the, yeah, OK. You can carve out the app. Oh, that's weird. You can carve out the app. the cluster into different namespaces. You can also federate across multiple clusters and multiple zones. And finally, if you have any questions, we actually have a booth outside from Campus Warsaw that's helping startups. And I'm going to be hanging out there in the afternoon as well. So thank you very much for your time. And these are some of the links you can follow to try this out yourself. So thank you very much.